Welcome back to Algebra 1, Chapter 11, Section 6 in this book. We've been simplifying things, fractions, and now we're going to add and subtract fractions. Now, if you remember, way back in your Wayback Machine, I'm getting my coffee over here, you remember middle school. And you remember that adding and subtracting fractions was a pain. Some of you even hated it, I must say. Well, it's a little bit of a pain in Algebra 2, because we're going to add and subtract fancy fractions. But let's review the rules, okay? If you're going to add or subtract fractions, they have to have the same denominator. And then you just write that denominator down one time, and then you write the adding on top or the subtracting on top. So let's look at a real example. A fancy math one, okay? So step one, we check. Do they have the same denominator? Check. Then all we have to do is add everything on top. So we have 5 plus x minus 5. 5 plus x minus 5. And then anything we can straighten out, 5 minus 5 is 0. So really those two cancel out. And then we're left with x over x, but anything divided by itself is 1, or those x's cancel out, but you're not left with 0, you're left with 1. So that's kind of funny, that this big fancy thing equaled 1. See, that's kind of fun, isn't it? Okay, how about this one? Do they have the same denominator? Check. So we just write down that denominator, 2x minus 3. Now we do the top, 7 minus 3x. There's nothing we can cross out. That's the answer. Ta-da! It looks hard, and it's a little confusing. Now, you will do this in Algebra 2, pre-calculus, college algebra, the SAT, the ACT, and college entrance exams. Math books really like this fancy math, and it's not hard if you just remember the basics. Denominators must be the same when you add and subtract. Okay, look at this one. Do they have the same denominator? Check. So we write it down. And then we do the numerators. 4x minus x, and this is where you have to watch out. That minus goes for this whole thing. So it's minus x, but it's also minus 2. And what do two negatives make? A positive. So it's 4x minus this, but this gets distributed. So then it's negative x and positive 2. Watch out for that. That one will trip you up. Okay? Now, you could be done here, but we can gather up some terms. 4x minus x is 3x. There's nothing to gather up with the 2, so it's there. Now, sometimes you can do more to it. Like you would think you're done here, but you can kind of see there's a 3x and a 2. So before you finish it, check and see if you can factor this. We could, and we can factor it into 3x plus 2 and x minus 1. So these are the same and can cancel out. So what we're left with is an understood 1 on top of x minus 1, and that's the answer. So that's kind of fun that such a fancy problem ended up with that little answer. Okay, how about this one? Oh no, they don't have the same denominator. What are we gonna do? Well, we gotta make them the same. And how you make them the same is you look to see what they need to be the same, okay? They both have an x, so that's all right. 6 is made out of 2 times 3, and 8 is made out of 2 times 4. This one has an extra x, okay? So what we have to do is anything that they have in common, like these 2's, or those x's, we don't have to worry about. But the things they don't have in common, the 3 and the 4 and the extra x, we have to give to the other one. Now, what do I mean by that? Okay, so this one needs a 4 from over here and an x. So I do x to the numerator and denominator, because you can do anything you want to a fraction as long as you do it to the numerator and the denominator, and I want it to have an extra x. I also want it to have a 4. It doesn't have one over here, so I'm going to multiply the numerator and denominator by 4, and then this will be set. What about this one? What's it missing? Well, it's got a 2. This one has a 4 and an x and a square now. So what it's missing is the 3. So I'm going to multiply the numerator and denominator by 3. So what I get for both of these is 6 times 4 is 24. X times x is x squared. 3 times 8 is 24. And there's an x squared. Now they have the same denominator. Let's straighten out the numerator. 4 times 7 is 28, and put the x there. 5 times 3 is 15. Now we can add them together. It's going to have this denominator, 24x squared, and the numerator is just 28x plus 15, because you cannot add those together. Remember, they have to have the same letters with the same exponents to be added, and they don't. So that's it. That's all we can do. All right, let's look at this one. This one has x plus 1 in this denominator and x plus 6 in the other denominator. So we need to give them what they don't have. This one needs an x plus 6, but if I put it in the denominator, I have to put it in the numerator. This one needs an x minus 1, but if I put it in the denominator, I have to put it in the numerator. Now I can FOIL this out, use the distributive property. X times x is x squared. X times 6 is 6x. 2 times 6 is 2x. 6x plus 2x is 8x. And 2 times 6 is 12. The denominator is this, x minus 1 times x plus 6 for both of them. And this one I can use the distributive property on too and get 12x minus 12. Now I need to simplify them all out. The denominator is the denominator. And now I need the numerator. To get the numerator, I need to gather up my terms. And I can look at this as just all one big thing. Remember how I told you you can sometimes look at it as one big thing? But this is a minus 12x, and this minus goes for the whole thing, so it makes it 2 negatives, and 2 negatives is a positive. Now, in this one big expression, I'm going to look to gather up my terms. So the only squared is this one, so I circle it and mark it out. Now I look for x's. I have that one and that one. 8x minus 12x is negative 4x. Mark them out. And then 12 plus 12 is 24. So x squared, let's see if they did anything x to it. Nope, that's all they did. Sometimes then you go back and factor this and see if we can mark something out. But I don't know if there's anything that we can multiply to get 24 and add or subtract to get negative 4. But there might be, and that's why sometimes one math book or one math program will have one answer and another one will have another one, because math teachers disagree on when to stop these things. When can you do one more thing? Oh, we can pull out a negative, or we can do something else to it. But this is where your book stops, so I won't even look to see if there's anything more to it. Alright, so this is section 6, learning more about simplifying. And remember, the adding and subtracting with fractions is harder than multiplying and dividing. So, but we're about to do a thing called dividing polynomials. So come back for that. It's fancy math. You'll have fun. Math is great.